Hello, my name is Eric Bowman, Residential Cooling Product Manager. Today I'm standing in front of our new uncased aluminum replacement evaporator coils. We're going to get these unboxed and tell you more about them. We have these aluminum coils unboxed now. They represent our 1.5 through 5 ton capacities, which represents our full line of aluminum replacement coils. They are identical in width, depth, and height of the coils they'll be replacing, which is our copper replacement coils and our tin plated replacement coils. What I want to talk to you next about is our 360+1 design philosophy. This philosophy delivers on our customers' expectation of performance, installability, and serviceability. Continuing our 360+1 design philosophy, I want to break down the components of our aluminum coil subassembly and compare it to our copper subassembly. First thing I want to talk about is the aluminum hairpin versus the copper hairpin. And obviously the biggest difference that aluminum affords us is the elimination of pharmacare corrosion. The next thing you'll notice is the thickness of the wall of the aluminum hairpin is 2.5 times that of its counterpart in copper. Also, you'll notice both of them are rifled on the inside, and that helps with the heat transfer and gives us equivalent performance between the two coils. The hairpins aren't noticeably different in the wall thickness, although the aluminum is slightly thicker, but it's made up of an alloy that helps us in the manufacturing process. Each one of these return bins is tapped into the assembly prior to being brazed, and this is much robust in that assembly process. The third component is the fin. Not a lot of difference in the fin. It is a different alloy. It's in contact with aluminum, and this is in contact with copper, so there is a different alloy, but as far as the fin pattern, they're both has a raised louver. Also, all of our aluminum coils are 3/8 diameter, whereas our copper coil is 5/16 from 1.5 through 4 tons, and then at 5 tons we go to 3/8. All the aluminum are all 3/8. The last component of the coil subassembly I'd like to talk about is the end plate, and another substantial gain in the integrity and performance of this coil. The current copper coil utilizes a G90 galvanized, which everybody knows can rust and produce red rust. Everybody's probably seen that if you've ever replaced a coil. With our aluminum coil design, we've gone to an aluminum end plate, which eliminates that red rust. So that makes up the full assembly of our coils, and next I'm going to talk to about the full complete coil assembly. Continuing on with our 360+1 design philosophy, I want to talk to the full assembly of our aluminum replacement coils. First thing you may notice is that it's an end coil design. This is very similar to the current copper coil, and this makes it a drop-in replacement whether you're replacing a furnace coil or an air handler coil on past products. The first thing I want to note is the copper stub outs. There will be no brazing of aluminum with this coil. These copper stub outs come from the factory, and when you take out the old and put in the new, it's copper to copper. The next thing I want to point out is the chat lift connection on the TX valve. This is a mechanical connection that makes it much easier to replace a TX valve with the exception that this fails. And also I'd like to point out the 45-degree angle. This 45-degree angle does a great job of eliminating any hammering noise of a TX valve. These coils being made out of aluminum means they weigh less. We have, on our largest coil, we lose up to 8 pounds reduction in weight. On average, these coils are about 4.5 pounds in less weight opposed to the copper predecessors. We factory leak test each one of these coils to 1/4 ounce per year. Their airflow pressure drop through these are identical to the copper predecessors, so you don't have to worry about any adjustment in airflow when you replace them. The drain connection is 3/4 inches, which is identical to the copper predecessor also, so there's no changing in the drain connection. and they're bidirectional flow, which means you can replace these in an upflow configuration, a downflow configuration, or a horizontal left or right replacement situation. The white drain pan is our furnace coil. It's high temp material, withstands the temperature coming off of a gas furnace. And the black drain pan is for our air handler coil. So that's an easy way to tell the difference between a furnace coil and an air handler coil. The next thing I'm going to do is actually show you the replacement procedure on a furnace coil and an air handler coil. I would like to demonstrate the replacement of a copper coil with our new aluminum replacement coil. I have an example of an upflow furnace and an upflow air handler. Obviously the other applications would be the horizontal air handlers or the horizontal furnace or even the downflow configurations. The change out of these coils are fairly the same whether you're upflow or downflow. I'm going to use the air handler, the upflow air handler, to demonstrate the replacement of the copper coil with the aluminum coil. I've taken the 5 screws out of the access panel, and obviously out in the field you would unbraze your suction and your liquid line after you pull the vacuum on the system. It simply slides out. You set it to the side. Now the aluminum coil comes just as you see it with the upflow drain pan. It does not have the angles that would be required for water management in the horizontal application. There's an angle here attached with one screw, another angle here, and one on either side of the coil, along with the horizontal drip pan that's attached by 2 screws. If I was going into the horizontal application, I most certainly would take these angles and install them onto the aluminum replacement coil. In an upflow configuration, you already have the upflow drain pan in there. I am not going to demonstrate that for the sake of time, so I'm ready to go. You simply pick up this lighter coil. There's a couple rails that you want to set it on, and it simply slides in. And now the coil's in there. Obviously, you would rebraze your suction and liquid line, pull the vacuum, reinstall the door, and you'd be ready to go.